Hello everyone. Now in last sessions, we have done some theory part. I'm sure you all must be waiting now for some illustrations. So it's high time we take some problems on relations. Let us start one by one. My first question is number of relations that can be defined on set A 1, 2, 3 is. And now I have been given some 4 options. When I read this question, now my thought process starts like this. That number of relations on set A means A cross A, I have to find. Means first I will have to write A cross A. Then after writing A cross A, all possible subsets I will have to write. Then I will have to see the number of subsets, etc. So let us do one by one. Number of elements in set A is 3. So how many elements you will have in A cross A? I have written that is nothing but number of elements of set A into number of elements of set A. Mind you, please first cross, that means A cross A, that cross I am talking about. That cross stands for the Cartesian product notation. And second cross what I have written, that is for normal product, I mean multiplication sign. Now I have written here Na into Na. Why do I say so? That it would be Na into Na. Now number of elements in set A is small. Let me explain one by one. If I have to write A cross A, how do I start? I will write 1, 1, 1, 2, 1, 3. I have written pairs first with 1. Then I go for 2, 1, 2, 2, 2, 3. Then I go for 3, starting with 3. 3, 1, 3, 2, 3, 3. So how many total pairs you have? That is 9. And that is what I have written. That number of elements in A cross A would be Na into Na, means 3 into 3. That is nothing but 9. So we have found number of elements in A cross A. Now question is regarding number of relations on A. And for number of relations, what do we need? Relations means it is subset. So is it not about number of subsets of that A cross A? So number of relations on A is number of subsets of A cross A. Then number of subsets of A cross A, it should be 2 raised to, I have written M, where M stands for number of elements of A cross A. This we have done in our previous sessions. That number of subsets, how do we find? If P is number of elements of set A, then 2 raised to P would be number of subsets. I am using that same result here. So now I have with me number of A cross A, means elements, number of elements of A cross A is 9. So how many subsets we are expecting? That should be nothing but 2 raised to 9. And number of subsets is same as number of relations. So it should be nothing but 2 raised to 9. So the correct answer is C. Let us move to second one. And the second one is, I have been given set A as 1, 2, 3 up to 10. And I am given a relation R. It is set containing ordered pairs x, y, where x plus 2y is 10. And mind you, please, I have written x and y both belong to set A. Now this is a relation and we are asked to find what is R inverse. I hope what is given to us, what is asked, that part is clear to you. Let us start. Now, don't you think that we will have to write, to get R inverse first, the relation R explicitly, though it has been given in the set builder form, that it is a set containing ordered pair x, y, where x plus 2y equal to 10. That definition is known to me, but I work on how to get that relation R first explicitly. When I say explicitly, I mean what all pairs would be in that set R. So I start with that, let me check what kind of pairs x, y I am expecting in capital R. I write y as x minus 10 upon 2 and I would try to calculate y for every x. Is it possible? Let us see one by one. If I substitute x equal to 1, it will become 1 minus 10 upon 2 and it is nothing but minus 9 by 2. We expect that y to be in set A and we are getting minus 9 by 2, which is not in set A. So obviously x equal to 1 cannot be in domain of R. Now one more element I check, say x equal to 3 and I do similar exercise and I get 3 minus 10 upon 2 as y. When I simplify, it becomes minus 7 by 2, which is not in set A. So obviously x equal to 3 also will not be part of domain of R. Now these two first trials are enough for us to understand that whenever I am substituting odd numbers in place of x, I'm not going to get element y from set A again. So we would try to give values to x only the even ones. And I start with x equal to 2, that leads to y equal to 4, then x equal to 4, x equal to 6, x equal to 8. All I substitute and I get y equal to 4, 3, 2, 1. Right? So that means we have found pairs 2, 4, 4, 3, 6, 2 and 8, 1. Put them in curly bracket and get your relation R. Now how do we get R inverse? We write those pairs in the reverse order. So 4, 2, 3, 4, 2, 6, 1, 8. These pairs would appear in R inverse. And the right answer would be nothing but option D. I hope everybody followed the procedure, how we moved towards R inverse. Tip of this question is that we first find R explicitly. It may not be given in the question, but you will have to work on that. Let us move to the next one. And the third one is that relation R from a finite set A having 3 elements to another finite set B having 2 elements is defined. Then the number of relations which are non-empty and proper subsets of A cross B is. This is we have to find. Now mind you please, again question is regarding the number of relations. We will have to work on number of subsets. So number of relations on A cross B, how did we find even in the previous question? It is nothing but number of subsets of A cross B. And how do we get number of subsets of A cross B? That depends on number of elements of first A cross B. It is given that set A has 3 elements. So if I am writing it, the number of subsets as 2 raised to p q, then my p would be 3 and q would be 2. So p is number of elements of set A, q is number of elements of set B. So let us apply this and I get it is nothing but 2 raised to 3 into 2, that is 2 raised to 6 and it is 64. So number of relations I have found, but question also has something extra in it. Question says that we want the non-empty one, means void relation is not allowed. And also it says the proper subsets. When I say proper subsets, A cross B is a set of itself and it doesn't come under proper subset. So realize that we will have to remove the void set and the set itself A cross B. So total number of the relations, the required relations would be, we will have to subtract 2 from 64 and it gives me nothing but 62. So these 3 examples were related to number of elements, number of relations, etc. Now some more examples you can try on your own and then you will have the grip on the topic. When we come next time, I will come with a new topic. Till then, stay tuned. Thank you.